Hi everyone,
Right.
welcome to another video of Open Source Spotlight. For those who don't know Open Source Spotlight, in Open Source Spotlight we invite open source authors and ask them to demo their tools. Today we have Vincent. Vincent is a familiar face to many of you, and in fact, I've known you for quite some time now. I start recognizing you on random pictures on the internet. So I was actually going through this website. So Maurice is one of our potential speakers, and then I saw,
Mauricia, yeah, I know her.
yeah, and then I saw this one, and I think, okay, I
Yeah,
know this guy.
yeah, that's me. Yeah.
Yeah.
Yeah, I
So
was so it was fun. Yeah, so I actually I made a joke to like a potential sponsor, sort of going like, "Oh, I know what you got to do. You should be the ball pit sponsor for PyData Amsterdam." And the guy said, "Sure, that sounds great." Then we had to arrange for a ball pit. But yeah, PyData Amsterdam 2019, we had a ball pit. It was amazing. Um,
yeah. So yeah, welcome.
right.
So what did you prepare for us today?
Right. So I kind of wrote two tools that are meant to be used together. And basically I'm just here to show off like one or two tricks. And I guess the easiest way to do that is to start sharing my screen, right?
That's right.
Screen share, desktop. There we go. And as always, we got to do like a little bit of a AV check. So I'm just gonna make sure that I can properly see you. I think that's good. And can you see me doodle now?
I can.
Great. That means that stuff is working. Cool. So I think last time when we spoke, I was talking about this Doubt Lab thing, right?
You did, yes.
Yeah. So like one of the things that one of the things I try to do is I try to make tools to make data quality like an easier thing to play around with. Because I think if stuff fails in machine learning, 9 times out of 10, sure, it can be the algorithm, but it's probably the stuff going into the algorithm. Um, But then one of the tricks inside of Doubt Lab that I thought was just kind of cool, like if I'm thinking about like, hey, how can I find maybe bad training data, bad examples, or stuff that I might need to check out? I kind of started thinking, well, it would be kind of nice if you have like a simple model and maybe a complex model. And whenever these two just kind of disagree, something interesting is happening. And that's a trick that's been, a story of my career. Like you take the simple domain thing and you take something that's a bit more complex, and if there's a difference between them, something interesting is at least happening.
Do you have an example? You
Yeah.
probably do. I'm pretty curious now.
I mean, so like, if you go to the Spacey video course that I made with Explosion like a couple of years ago, I try to find programming languages, and there at some point, so I have some rules that say if the token Go appears and it's not a verb, oh, then it's probably the Go programming language. Okay,
Okay.
a pretty simple rule. But then at some point, the neural network said, oh, wait, but Go version 6 should also be part of the entity. Ah, okay. So I think I have a pretty reasonable rule, but when it disagrees with the neural network, there's either an opportunity to make like the simple model better or the complex one or your training data. But then, the question kind of is, it would be nice if I can just very quickly and easily make a complex model. And especially if you're doing stuff with text, right? What you kind of want to do is you kind of want to take the simple bag of words model, maybe, and whatever big hugging face mega BERT thing that people have these days, right? Like it'd be kind of nice if you just put those two things together. And, bag of words that's super easy to make in scikit-learn. But the moment that you then sort of say like, oh, I want to try out the BERT stuff, it'd be kind of nice if you can still use a scikit-learn pipeline for that. That was kind of my thinking. And then I started thinking, it's a lot of these situations where you are working with embeddings, and it'd be kind of nice if you did like, oh, I want to use this embedding, and then I got to use PyTorch, or I want to use this one, and I got to do TensorFlow. It'd just be kind of nice if you could just say, no, I just want in the scikit-learn pipeline. And if you think about it, it's a scikit-learn transformer because text goes in, it goes through some sort of an embedding, and then a numerical array comes out, right? So there's no reason why this shouldn't work inside of the scikit-learn ecosystem. We just need an implementation of these building blocks. Back when I was at Rasa, I made a library called What Lies that did this for word embeddings, but the goal of that library was kind of more to be a visualization tool to sort of explore word embeddings a bit more. So I wrote a tool that I think is better, and it's called Embetter, pun intended, which is basically
Better.
Embetter. So it's like embeddings, but kind of for scikit-learn and tricks to also make them better. That's kind of the pun that I went with.
I love so
And
much the names here. Like I don't know how you come up with them, but they're so ingenious, and each one is better than the previous one.
well, I don't know if they're like one thing I will say that I think
They're cool.
helps. I'm pretty dyslexic. So like words, I experience words very phonetically, and I sometimes mispronounce a word, and then I consider, oh, it's actually like an amazing name for a Python package.
That's
Like,
professional deformation, right?
yeah, but I think I also have this toolkit with like my NLP tricks, and I call that token wiser because it's like some of my wise guy tricks. But anyway, I'm not here to talk about that. I'm primarily here to talk about this embedder thing first, because right now it has a bunch of embeddings for text and a bunch of embeddings for images. And what I would like to just show you real quick is how just the code of this kind of works. And once we've convinced ourselves that the code works, I'm going to show you another fancy trick that you can do with this. But the code is honestly relatively simple. So right here is like, if you're used to scikit-learn, you've probably seen the make pipeline function before, right? You can pre-process and do all that. So I have the library Embetter loaded here. I have a column grabber, which can just grab a single column from a data frame, turn it into a list, and then that can easily be passed on to a sentence encoder. That uses the sentence encoders package. sbert.net is the website for that, I think. And you just pass in the string of the model that you're interested in using. I think this is the base setting, which is for English, pretty good. If you're doing something with multilingual, I can highly recommend the LawBase model, in case you're doing that.
Which website did you like? I didn't hear this.
I
Where is it coming from?
It is sbert.net, I think. Yeah, so sentence transformers, that's the name of the package. It's maintained by a person whose first name is Nils, I think, and I forget the last name, but this is a cool package. Well written, has a bunch of useful features in it. And the main thing that I kind of like is you don't have to think too much about it, because many of the pre-configured settings are just quite reasonable. Because that's one of the downsides of PyTorch and TensorFlow sometimes, is there's just so many hyperparameters, you kind of get lost in it. But here you can go to the pre-trained model section, and there's all these different names of models with all sorts of different properties. And it goes down a bunch. There's tons of models to pick from, and this page also has some multilingual models as well. But yeah, all that stuff's great, because it means that with just like a one-liner, I now have BERT models ready in scikit-learn, which is kind of nice. And just to give a quick demo, like stuff you can do now if you have this, right? Some of that zero-shot stuff people like to play with?
Have you heard about this?
Well, I mean, it's not necessarily exactly zero-shot stuff, but like just a trick, right? Suppose I have no training data whatsoever, but I'm interested in doing sentiment. I mean, what I could do is just make a two data points training data set where there's this one sentence that's obviously positive and another sentence that's obviously negative, right? Then what's going to happen is those two sentences are going to get embedded. So like in some sort of high dimensional space, you're going to get like one data point for a very positive sentence, like another data point for a very negative sentence. And let's select a fancy new color for this. Let's say that there's like a new data point coming in. There's like some new data point over here. Then you can just kind of say, well, is the distance to the positive point smaller than to the negative one? If so, let's pretend it's positive. And because we have this embedding at our disposal, it should have some, pre-existing knowledge. This is a really easy way to just get started. And you just need a k-neighbors classifier with like one neighbor.
I'm still not sure how it works. So do you say that it first takes the word pause and then creates an embedding for that? And then
it's slightly differently. So pulse is just the name of a label. So let's go over that just a little bit slower. So this example, this is great. It's amazing.
So you say that for this one, it's positive. For that one is negative. And then the new ones, you will try to find which one is closer to.
Yes.
Yeah, I see.
And again, you could also use a logistic regression, I suppose, here, right? But the benefit of having like a k-neighbors classifier, the moment you start having multiple classes, You can just say, oh, here's a couple of obvious examples, right? And again, it's just a getting started trick, but building this is super easy because the main thing that does most of the intelligence is this one liner over here. And again, if you consider that we just have a bunch of things at our disposal, like I can do a whole lot in just a single cell. So I've got this example over here, like this is great, it's amazing, exclamation point, positive. I totally hate this. I can give it new text saying that's just wonderful, or oh no, this is bad. And yeah, even though I'm using completely different words, right? Count vectorizers would fail at this because it hasn't seen these words before. It is able to give like the same predictions that I would expect. So that's like a thing that you could do with this. But because we're in scikit-learn country, like nothing is stopping you from using any of the other tricks. So, you know, let's say that you're training this on something that's a little bit more domain specific. So maybe there are some words that are like, I don't know, super biomedical or something like that. Something that might not be in the corpus that the sentence encoder was trained on. Well, nothing is stopping you from just saying, well, just add a count vectorizer. Just add count vectors next to this sentence encoder, and that's now both features, and we can just pass that forward to logistic regression. That's also totally possible here. And again, like I don't want to suggest that this is, if you fine tune the model, you could probably get like a better performance. That's definitely true. But in terms of getting started, this is like a minute, right? And that's kind of what I'm going for. I want, if people are playing around with embeddings, I just want to make that as easy as possible. And I think I've hit like a pretty nice abstraction here. Another thing that's kind of nice, if that's like your thing, it's a bit of an advanced scikit-learn trick. Like all the tools inside of this package also support partial fit. So theoretically, if you are you know, if you're interested in doing something like this, but you're generating batches of data, maybe because you're introducing spelling errors and stuff as well, we can also accommodate that with this tool.
What is a partial fit? I know what fit is, but what is partial?
So the idea here is that some scikit-learn models, like usually you have like X, right? That's your big data set,
Yes.
rows, columns. But what if this is too big to fit in memory?
Okay. Then you split it, right? And you chunk it.
Then you chunk it up. But then what you do is you say, well, let's give this chunk to the model, and this will be a partial fit. It's kind of like an online learning kind of a thing.
Okay, so partial fit, it means you don't start from scratch. Whatever weights you have, you continue learning, right? So you don't reset the weights.
Yes. And of course, like if you're doing that, I mean, there are some dangers, right? Because let's say if the data over here is very different than the data over here because there's time involved, let's say. I mean, if you're doing partial fit and you're doing that like once, like, there might be some bias, right, in terms of the order here. So what some people like to do is they like to sort of randomly shuffle stuff and pass that through. The main trick that I like to use this for is, let's say I have my big data set X. Let's say I split that up. But then every time I feed it, I make the subset twice as big. And like this is the original subset, but this one might have some spelling errors in it. You can generate spelling errors by
augmentation in albeit, right?
Exactly. But this is like something I really like doing if I'm doing chatbot stuff, because spelling errors are super common there, right? And then you just loop over this like 10 times with new spelling errors every single time around. And it's pretty robust. Around Christmas, expect another package from me that does some of these hashing tricks. But for now,
looking forward to that.
Embeddings. So I hope you're looking at this and kind of going, this is kind of nice. Just single line of code, pretty cool. And with this, you can also say, well, let's make a very quick bag of words model, and let's compare that to like an embedding model. And if there's a difference, it's super interesting. So that's like a pretty cool use case for this. But there's another one that I kind of want to show you. Because I also wrote this other tool called bulk. And here's what bulk allows you to do. So what I've done is I have this data set called clue-starred. Forget the name, but it has like some text in it. And it also has these X and Y coordinates over here. Now, what I did is I said, well, let's take that text. Let's pass that through this embedding thing. And then let's UMap that. That is to say, let's do dimensionality reduction, such that where here I have an n-dimensional array for each line of text, here I have a 2-dimensional one. The thinking is that when I do this, I can make two-dimensional scatter charts. And that maybe clusters of text start appearing. And then it'd be kind of nice if I just had like a visual tool that allows me to make a selection in that cluster domain, because, I might be able to do like very quick labeling that way.
Okay.
So let's open that up.
Oh, but where, like, what does the name mean? I'm seriously interested. Like you said, you said forget about the name, but I'm really curious. What does it mean?
So the question is, what does bulk mean?
No, the name of the data set.
Oh, right. So I used to have a package called ClueStar. That was my first attempt at this. Come on, Wi-Fi. Come on. There we go. And ClueStar allows you to do this. It's basically like something you can use inside of a notebook, and you can just sort of make a selection in this two-dimensional chart, and you can see what you've selected on the side. Okay. So the first data set that I ever made for this library is cluestar.csv.
Okay.
And that's kind of where it just comes from. The only downside of ClueStar is, this is great. You can kind of get an impression of, oh, these clusters exist. But what I kind of want to do is I want to say like, okay, now take this cluster and save that in a separate CSV file because they're about the same topic. And then I can give that to like a proper labeling tool, and I can very quickly go yes, no, instead of selecting the class that I'm interested in. Yeah, so that's the origin story of ClueStar. You can still pip install this if you want to use it from a notebook. I suppose that's fine. Just to check if this is now also the most recent one. I think so. Oh, okay. Let's try that again. Oh, yep. Again, what we're looking at here is the steps were take this text, give that to an embedding model, and something BERT in this case, something that takes a sentence, makes a big embedding, and then pass it on to UMAP. And then I get this sort of two-dimensional thing that you see over here. And the only thing that bulk allows you to do is it just allows you to make like a quick selection. And I've just selected some of the points here. And then I can just have a look at the text like, hey, what is this actually about? And these are tweet messages. And you can kind of see it's all about Christmas. All right. So I could say like, hey, Christmas.csv, boom. And now locally, I've got a CSV file with just these Christmas examples in it. But I could also explore further. And again, like if I'm doing topic modeling in the beginning and I'm trying to figure out what it's about, this can just be very useful in terms of like getting started quickly. Because again, there's knowledge in this embedding that I can sort of reuse. But I will say like without any colors or anything, it is kind of tricky to figure out like, hey, where are the clusters that I might be interested in? So like one small feature that I've added, shortcuts, go back to VS Code. There we go. So like one thing that I am able to do as well is I'm able to add like keywords, and then these keywords themselves will actually appear as colors. So I'm again grabbing a browser and moving it over here. And now it's the exact same interface, but there's colors around now. And now I can kind of say like, oh, there's like a chunk of stuff here about the website, maybe. You can kind of select that. And then, oh yeah, website is down. I can't get the website on my phone. Any reason? Your shop has crashed. Nightmares. All right, this is kind of useful. Now, one thing I do want to point out is like when you make a selection like this, it's not going to be perfect. It's like very important to keep in the back of your mind. Like you could go ahead and feed this to an algorithm, but you're going to get some bad labels in there. But the point here is like this should be useful when you're getting started, when you don't have any labels whatsoever yet. And what I will say is like very easily, I am able to say like, hey, at least if nothing else, these all seem to be complaints about deliveries. I mean, maybe it's about the delivery driver or something, but I should very easily be able to say yes, no on this class. And I should be able to do kind of the same thing here on this website.
Do you actually need to go through this process? You can just select all the words with delivery in it.
So one thing about, let's see if I can go here. So one thing here, right? Theoretically, you could say, hey, the order never arrived. And it's about delivery.
Right.
But the word delivery doesn't appear in it. So I was able to cherry pick an example there once. Order. Yeah, so.
Oh, they have delivery, but I see what you mean. Yes, I
Yeah,
can
so
imagine that there is a case there where delivery does not appear.
exactly. So the thing is, for sure, nothing is stopping you from keeping it simple and just taking the word delivery, right?
Mhm.
But I will argue the benefit of this approach is that it can kind of go a bit beyond that.
Mhm.
That's the thinking, the hope, I should say, right? Because it
Yeah,
is
that's
still a bit
fair.
of a gamble.
Yeah.
It's a bit of a gamble still, because not all these embeddings are not perfect. But yeah, this is kind of a nice trick. And I hope you can also kind of see here that I'm kind of building this sort of suite of tools where if it's just super easy to have like these embeddings available, they're just a couple of use cases that immediately pop up. Now, one of these use cases is you can use it for text while you're doing bulk labeling. So, all right, pretty cool. I thought that was kind of this on its own. This is kind of a cool demo, but we can go a step further because we're also doing vision stuff. So technically, I could do the same thing. You have an image, and again, the image can also go through some pre-trained embedding model. And then again, I also have my n-dimensional array. I can once again pass that through UMap. Nothing's stopping me to do that. And again, I have this two-dimensional thing over here. But one thing that's a bit tricky with images is like, it matters a bit more what happened with this pre-trained model. Because I can imagine, positive or negative sentiment. Yeah, okay, that translates kind of well across data sets. But pictures of fire hydrants aren't great if you're interested in medical images. and like, I can definitely imagine like a pre-trained model for images is quite domain specific quite quickly if you're not careful. So there's another trick. For that, I am going to open this notebook that I have over here. Let's just make that a bit bigger. There we go. And what I'm doing here is pretty much the same thing as before. I'm saying, hey, let's grab a column. And in this case, I'm grabbing a path. Then that path is loaded up by an image loader that takes the path of the image and that turns it into a Python image library object. And then I have this PyTorch image TIM encoder. I think that's a PyTorch image module. There's a abbreviation for that. And then I can say, hey, let's pass that through the exception pre-trained model from 2017 or something. And what I'm doing here, by the way, is I'm giving it images like this, like some cats and some dogs for like pre-trained breeds or something like that. But to my knowledge, exception is not trained on cats and dogs, but it is trained on specific breeds of cats and dogs.
Yeah, ImageNet has everything, right?
Yeah,
I
so
mean,
I think
usual
it's
stuff.
exactly. So, but I don't think cat or dog is not part of ImageNet, but I do think
I have no idea.
bulldog
I never
terrier, I
checked.
believe is. I could be wrong, but that's my impression at least. Okay, so let's then do a very quick one on bulk with those embeddings. So I can pass those image through exception, and I can have this look at this, two-dimensional plot once more. There's also kind of a nice little demo because Bokeh definitely supports images now as well. This was done like 2 weeks ago. So I can again make kind of a selection here, and then you sort of see the images of the dogs that you've selected. And here you can kind of go like, oh, okay, this is the Chihuahua cluster, sort of like in the upper corner over here. And maybe if I go down here, okay, there's definitely like cats cluster over here, so that's pretty sweet as well. But then there's like stuff in the middle here where, okay, there seems to be different kinds of dogs, so that's kind of nice. But the moment you go a bit bigger, it kind of becomes a mix, or like it's not necessarily clear when there's cats and dogs, and like a pug with a cat. Okay, it kind of gets fuzzy, right? So then the question kind of is like, can we maybe fine tune these embeddings for our labeling purpose? Like if I'm mainly interested in cats and dogs, I mean, I do think it's pretty interesting that like some of the features that are detected here, I mean, these pre-trained convolutional nets, they probably have detectors for ears and maybe also like the shape of the ear, right? So like you can have a very pointy ear that's kind of like a cat. You can have like a very flappy ear that's kind of like a, dog, so to say, right? Smile, doggy. So like I can definitely imagine like useful features got picked up here. But if my end task is cats and dogs, then I might want to do something different. So what did I do up front? I spent 2 minutes annotating. So I can spin up this little Prodigy server over here. And I can kind of open it up. And I can, again, push that below here. So, very basic labeling interface. Is this a cat? Nope. So no, not a cat. No, not a cat. No, yes, a cat, etc. And I just label 50 images this way. And when I do that, I have a data set, albeit a very tiny one. But that data set is big enough to do this one trick. I have my embedding model over here, right? So image, embedding model. And then I could put my own little task head on top of it. And that's just going to be yes, no, cat, dog, so to say. But this could be a neural network. So I could say, well, I don't know, like 300 neurons here and a single one over there. And what I'm then going to do is I'm going to train just the task head. So, gradient update. It's going to update this dense layer as well as, all the weights going forward here. But it's not going to update anything over here. And in doing so, what I can do is I can say, let's not take this embedding over here, but let's take this one. Because this will have combined some of the knowledge of the embedded space from our pre-trained model with the label that we are actually interested in. And kind of the cool thing is, the code is online. You can have a look at it. But just the shape of the UMAP chart. So this is the UMAP chart we had before. And if I do this pre-training task head, pass that through UMAP, this is the new UMAP chart. And you can kind of see like a line here, right?
Mm-hmm.
So maybe one end is dogs, the other one is cats. And like there's kind of like a confidence thing happening over here where the stuff in the middle is probably like, we're not sure if it's a cat or a dog. So I also ran that, and I can run that with bulk. And I got to do the screen clicking and dragging thing one more time. Hopefully the last time. Click and drag. And let's have a look. So let's grab something from this part. All cats, like pretty obviously. Over here, all dogs, pretty convincingly. And if you go in the middle here, it's still a bunch of cats, but some dogs as well now, right? If I go a little bit more in the middle here, it's definitely more of a mix between cats and dogs. Still a lot of dogs, but this is where it gets a bit tricky and a bit uncertain, at least. So that means that I can sort of say, well, if you want to have a data set with more obvious dogs and obvious cats, I can quickly make that selection. And I can also make a selection kind of in the active learning way of thinking of like, hey, now I want to make the selection where stuff is just a little bit more uncertain. And it's not a whole lot of work to build this. Like you just need a couple of scikit-learn pipelines and this visualization trick to sort of get there. And again, all I got to do is then save this. This is definitely dogs, let's say. Here's a selection, and these are definitely cats. And here's a selection. I'll call that dunno. And if I now go back to Visual Studio Code, I need to refresh the page, and then I should have. Where am I running? This might be a small bug, but then I need to double check this. This might be a bug, but there should be a CSV file here with that information. And then you can pass it to Prodigy.
You'll fix it after the demo, right?
Yeah, so this is one of those, this is awkward. I got to fix that. Maybe edit it out. We'll see. But this is something I do find like pretty exciting. Like for all the cool things that deep learning does eventually give you, I do think the user interface, the more we can keep it in scikit-learn land, it's just a bit simpler.
Mm-hmm.
And I like having these Lego bricks that you can just kind of quickly play with.
You have is it Scikit-Lego?
That's also a project that I'm not the only one. But this line of thinking actually started here. You're definitely right there. So like a couple of years ago, me and a former colleague, Matthijs Browns, we just noticed that some of my colleagues were implementing the same thing over and over again at different clients. And like I was actually teaching some people how to like commit to open source. So I actually convinced some of my clients to commit to my open source project as a part of their educational endeavor. But this is just a huge collection of just components. So like data sets, fairness tools. The whole thing about this library is it's kind of all over the place, but it mainly targets tabular data. Since Scikit-Lego, I have tried to limit the scope a bit for open source packages, because I do think it's just kind of useful that like you pip install a trick and it's just a small little trick instead of it trying to do everything. But yeah, this project is pretty popular. We almost have 1,000 stars with like 50 contributors at this point. So once in a while, there's like a person who has a pretty neat trick, would like to have that in a library, but doesn't feel like maintaining a library. And then the whole point of Scikit-Lego is that this can be a home for those kinds of things.
Okay. Yeah. So do you have any advice for anyone who's watching this?
Use my packages. So keep it simple, I suppose. Like, and also maybe like, a lot of people are surprised when they hear like, "Oh, Vincent, you make a ton of packages," but I hope that people also understand that I write these packages to make my own life easier. So it's not necessarily that I'm out there making all of these packages because that's my life goal. I'm making all these packages because I don't feel like rewriting the same code over and over again. And when I recognize that something can be reused, that's great. In terms of like I am interested in feedback, especially this bulk labeling experience. And that's definitely an experiment. So, you know, there's still some open questions in terms of how accurate is it actually? Is this better than active learning? Maybe not, right? So there's still tons of any feedback on that will be super useful. One thing I do want to mention is that right now I have this fine-tuning thing in a notebook. I'm probably going to make that into a scikit-learn component as well. Because you can also say like, hey, how about I just have like a fine-tune component where when I fit, that's where I'm adding like a task head. And when I transform, that's where I'm going to take that dense layer and feeding that forward. So there's still like some things I can do to make these embeddings better. Name. So if people are interested in that, again, feedback will be welcome, and people should definitely keep an eye on that. But the most general advice is, even if you're working in a Jupyter notebook and you're working mainly with pandas, but you find yourself using the same functions all the time, put them in a package. It's easier to maintain.
Yeah, thanks, Vincent. Always pleasure to have you.
Cool. Thanks for having me.